All right, compared to trig substitution, integrating using long division is going to be very straightforward, for lack of a better way to say it. So let's talk about what you need to do. So there are a couple different rational function integrals that we're going to be talking about. And upon investigation, once you look at what they look like at the very, very beginning, you're going to want to look at, is the exponential factor in the top, the degree of the top, greater, equal to, or smaller than the bottom? If you have a rational function, meaning a polynomial over a polynomial, where the numerator's degree is greater than or equal to the denominator's degree, you need to do long division and simplify that rational function. So I am going to do that over here. You can use synthetic as well. Just make sure you use the 0. So you'd use -1. But I'm going to go ahead and use long division. And also long division always works where synthetic division only works when you have integer zeros in the denominator. So there's that. Okay. X times x gets me x squared. X times 1 gets me x. I then subtract those. I get 2x plus 5, so plus 2. 2x plus 2, subtract, and I'm left with 3. So this rational function is the same function as x plus 2 plus 3 over x plus 1. If I do long division, taking x plus 1 and dividing it into the top, these are the exact same functions inside that integrand. This is now something that I can take the integral of. So I get 1/2 x squared plus 2x. You can think of this here as like a u sub question. If you let u be the bottom, it's a linear term with a slope of 1. So my du would just be dx. Super straightforward, 3 times the natural log of x plus 1 plus c.